Hey there, y'all. Today we're going to look at 2.3 on solving equations with variables on both sides. And so in this section, we're going to look at equations that literally have variables on both sides of the equal sign, and that's what you're going to be able to solve. We're continuing those AREI standards of 1 and 3 that we talked about in 2.1. And so let's look at some examples of how to solve equations with variables on both sides. And so looking at example 1 here. We've got 4x is equal to 7x minus 12. Now, the key to solving equations with variables on both sides is first get the variables onto one side. So your first step before we go and work PEMDAS is to get the variable on one side. Now, we still have to use our order of operations to do that, but we want to get it all to one side, and then we can work from there to get the variable by itself. And so in this case, we see that I've got a 4x on the left side of the equal sign and a 7x on the right side of the equal sign. And so we've got to move these to the same side. Now, we can move the 4x from the left side to the right side, and we would need to use subtraction. Or I can move the 7x from the right side to the left side by subtraction as well. There's issues either way that you need to just be careful not to fall into. Okay? So if I subtract the 7x, 4x minus 7x is negative 3x. And that's equal to the negative 12 that's left over. Be careful with your signs here. That's the pitfall of this direction. Okay? Our next step, divide by the negative 3, because now we're working our PEMDAS, right? Step 2 would be to PEMDAS, right? And then we're dividing by the negative 3, so x is equal to positive 4. And if we check this answer out, 4 times 4 is 16. 7 times 4 is 28, and 28 minus 12 is 16. So this does check out. Now, if you get good mentally, you can do a check like that as well, where you don't have to write out the full check and write out 4 times 4 is equal to 7 times 4 minus the 12. And then to get 16, is that equal to 28 minus 12? And then we see that 16 is equal to 16. It checks out. So again, if you get good enough at this and you can recognize it and not make those mistakes in your head, you can check it quickly in your head in the end. But I would not recommend doing that unless you're super confident. Okay? Let's look at example B. This one's a little different. Now we've got variables on both sides. And we've also got constants on both sides. And so here's my recommendation when you have variables on both sides. Now, the first problem, I moved a certain way, and this will actually go against this general philosophy I have. I always like to move the smaller coefficient. And so negatives will be smaller than positives, right? And so in this case, I want to move the 5m to the side with the 6m. Here's why. Watch what happens when I do this. I subtract 5m from both sides. This cancels. I get negative 18. 6 minus 5 is 1, so this leaves us m plus the 4. So when I move the 5m to the side with the 6m, I'm subtracting, and 6 minus 5 gives me a positive. But if I were to move the 6m to the side with the 5m, 5 minus 6 would give me a negative. So while I can move it either direction, okay, so don't get me wrong, you can move whichever one you want to the other side to get the variables on the same side. I would recommend, and this is just to deal with sign issues and deal with like if we have inequalities as we go towards those sections in section 5 and 6 and 7, dealing with it to get less signs involved, okay? All right, so now we're finishing off solving this. The m is here, so I need to move the 4, so subtract 4 from both sides. That cancels, so m is equal to negative 22. And if we do our check, make sure you plug it in everywhere. Everywhere you see the m, you will plug in that negative 22. 5 times negative 22 is negative 110. 6 times negative 2 is going to be negative 132. And so negative 110 and negative 18 is negative 128. Negative 132 and positive 4 is negative 128. So this does check out. That m is equal to negative 22. So again, don't be afraid if you get an answer that's a larger number, or if it comes out to a fraction or a decimal. They can happen. So don't fret on those, okay? So let's go on and look at one more example of these. Example C is not much different than the first two. The only difference is that we have parentheses here to deal with. And remember when we talked about those parenthesis problems in section 1 and section 2, we can either distribute that 7 in this case, right? Or we can divide both sides by 7, because remember the 7 attached to that parenthesis is multiplication. So which one's going to be easier to deal with here? Well, if I divide both sides by the 7, the right side does not reduce nicely. Like, it's not like I've got like 21u and 14, which will both divide by 7. I've got a negative u and a negative 11. They don't divide by 7 very well. So the better move here is to distribute. Now, if you want to divide both sides by 7 in step 1, be my guest, you'll get a fraction, and that's fine. If you're happy working with the fractions, go for it. That's you, okay? I like to try and keep things as simple as I can until the very end. And so this is the line that we get. We get 49 minus 21u equals negative u minus 11. Now we go back to step 1, right? Get the variables on the same side. And remember, I like to move the smaller of the two. The smaller of the two, which would be the one further to the left on the number line, is negative 21 compared to negative 1. So I'm going to add 21u to both sides. And so this will cancel. 49 is equal to 20u minus 11. Now we're going to, here's our u here, so I need to move the 11. So adding 11 to both sides, this gives me 60 is equal to 20u. In our final step here, divide both sides by the 20. And so u is equal to 3. And again, check our work. So 7, parentheses 7 minus 3 times 3, close both parentheses, equals negative of 3 minus 11. And so simplifying in here, we're going to get 7 times 7 minus 9. Is that equal to negative 3 minus 11? So you can see I've dropped the parentheses here, did the multiplication here. So 7 times negative 2, is that equal to negative 3 minus 11 is negative 14. And then 7 times negative 2 is negative 14. And that does equal negative 14. So remember that each side of the equation works on its own. So that's why you're able to kind of do like, oh, I'm doing inside parentheses over here, but I'm doing subtraction already over here to get it simplified. And if that's too confusing for you, work one side of this equation, just work it down, leave the other side blank, and then go and work the other side separately. So again, you can kind of separate out the two sides and work each piece individually down to its individual number. Okay, so again, all the problems that you're going to see on this are going to look something like this. You're going to have to move things around the equal sign and get it solved for. Okay, so next we're going to look at a couple of special problems that come out of this. So in example 2, we're looking at some special solutions. And so let's see what happens in example A. We're given 4 parentheses, 2x minus 5, is equal to 8x plus 7. Now, I tell you that this is going to be a special solution, but I want you to see what's going to happen with this problem. Because the work is still the same, it's the end result that becomes different. And so our first move here, now I could try and divide by the 4, and it will divide from the 8, right? But the 7 here, it's going to give me a fraction. So let's just distribute the 4. So 4 times 2 is 8, minus 4 times 5 is 20, and that's equal to 8x plus 7. Now, we want to get the variables to the same side, right? And so, well, I got 8x and I got 8x. Well, neither one's smaller, right? So, does it matter which one I move? No. So, let's subtract just 8x from both sides, right? Because if I do this, I'm subtracting 8x to this side. If I do this one, I'm subtracting 8x to this side, right? It's the same step. But watch what happens. 8x minus 8x is what? 0. So this cancels, right? But I come over here, 8x minus 8x, that's 0, so it also cancels. So I get negative 20 is equal to 7. Huh? Negative 20 equals 7? That doesn't make any sense. Negative 20 has to equal itself. Negative 20 can't equal another number. And so what this comes out to is a false statement. How can one number equal a different number? It can't. The basic properties of math say that every number is its own unique number. And so this comes out to a false statement. It's not true. And so because we get a false statement, what that means is there is no value for x that I can substitute into this problem and make it a true statement. And so the actual answer to this problem, because remember we're trying to find the solution, right, is that there's no solution to this problem. There's no value of x anywhere on the number line, negative infinity to positive infinity. There's nothing that will plug into this x and make it a true statement like we could in the first few problems. Let's see what happens in B and see what happens with that example. So in B, we've got 8x plus 14 is equal to 2, parentheses, 4x plus 7. In this case, if I try to divide by the 2, both these are even, so I can actually divide both sides by the 2. This will cancel this, and this will become 4x plus 7 is equal to 4x plus 7? What just happened there? Look at both sides of this equation. What's happening? Let's see the next step here. So our next step, like the previous problem, right? We want to get the x's together on the same side. And so I've got 4x and I've got 4x, and so they're the same. So we're going to subtract the 4x and we're going to subtract the 4x. So 4x minus 4x is 0, so that cancels. And 4x minus 4x is 0, so that cancels, right? And so I end up with 7 equals 7. Well, that's a true statement, right? Because like we would get 7 equals 7 when we're checking our work, and yes, it works, right? But that's not what happens here. This is a little different. This was when we were solving the equation that we got 7 equals 7. And so there's no variable left, right? We don't have like x equals 7. We have a statement that we have to judge as true or false. This is a true statement because a number is equal to itself, right? And so what that true statement means is actually the opposite of what we got for a false statement. In a false statement, there was no solution to the problem, right? There was no x I could plug in and make it work. Here, I can plug in anything for x. Any number from negative infinity to positive infinity will be a solution here. And so the answer to this problem is that the answer is all real numbers. Any number along the number line, from negative infinity to positive infinity, will be a solution to this problem. And we could plug it in to check, right? I could plug in x is equal to 5. I could plug in x is equal to pi. I could plug in x is equal to negative 27 over 7, right? Any of those values would work. I could plug in a billion. It would work, okay? So understand, when we get all real numbers, any number across the number line will make this system, this equation, true, okay? All right, we're going to look at a couple of application problems, and then we are done with this lesson, y'all. So the first application problem we're going to look at is a consecutive integer problem. And these problems are a little different, but we're going to work through this word problem and talk about what we have going on. So remember, you want to highlight key information, circle key information, whatever you're going to use, but pay attention to the keywords here. All right, first off, the sum means what operation? Sum means that I'm going to be doing what? Addition. Okay, so whatever follows, I'm going to be adding it together, right? The sum of what? It says 3 consecutive integers. Okay. Now, pay attention. I'm not doing like just the number 3 here. Okay. But I'm doing consecutive integers. And so, back to our definitions back in chapter 1 about the real number system, right? What is an integer? Remember, an integer is any number that's not a decimal and not a fraction. So like -2, -1, 0, 1, 2, going out both directions, right? Not a decimal, not a fraction. So, what would 3 consecutive integers look like? Well, if I start with the number 11, what would be the next consecutive integer? Remember, consecutive means one after another. So what's the next integer after 11? Well, it would be 12. And what would be the next number after 12? 13. And so that's what we're talking about when we talk about consecutive integers. Okay. Now, the answer to this is not 11, 12, 13. Don't think that that's the answer here, because it's not. Because if we add all those numbers together, right? Because that's what we're told to do. We're finding the sum of this, right? 11 plus 12 plus 13 only gets you to 36, not 105, because that's the next part of the problem, right? We want all this to equal to what? 105. And remember that word is your equal sign, right? So how can I make a equation that I'll be able to solve to find these integers? Well, we first got to define that one of them is going to be a variable, right? So typically what we'll do is we'll say that n is the first integer, which will also be the smallest of the set of integers that we have. But how do I go from the first integer to the second integer? What do I have to do to go from 11 to 12? You add 1, right? And so my next integer is going to be n, because we don't know what it is, plus 1. So this is the second integer. And then the third integer is going to be what? Well, it's plus 1 from this one, so it's n plus 1 plus 1, which is n plus 2, third integer. And so I want the sum of all this. So I'm going to take this n plus 1, and this n plus 2, and add them all together. So the statement's going to say n plus n plus 1 plus n plus 2 is equal to what? 105. And so what we've got all of this that needs to get added together. Okay? And so n, and n, so that's 3n. 1 plus 2 is 3. That's equal to 105. And so we'll now solve this. So we subtract the 3. 3n is equal to 102. And we're going to divide both sides by the 3. And so n is equal to, this is 34. And so that means that the first integer is what? 34. Which means the next one is 35, and the final is 36. So that's our three integers. This is the final answer to this problem. And the way to check it is take 34, 35, 36, add them all together, and you get what? 105. So one last example to look at, and then we're done with this lesson. So in the final example we have here, Bobby worked 3 more than twice as many hours as Adam did. How many hours did each work if they worked 48 hours? So key information here. Okay. So first we have Bobby and we have Adam, right? And so we're told that Bobby worked what? 3 more than. Remember that phrase more than means what? Addition, right? But anytime we see that phrase more than or less than, that puts it at the back end, not the front end, right? So whatever I've got, it's going to be plus 3. 3 more than what? 3 more than twice as many hours as Adam. So how are we going to represent that? That is 2a. Because twice as many, remember twice means times it by 2. So 3 added to 2a, right? And so that's equal to what? Well, it says how many hours did each work if they worked 48 hours. So what we now have is that this is equal to B, right? Bobby worked 3 more than twice as many hours as Adam did, right? And then what we're told is how many did they work if they worked 40 hours, right? So the hours that Bobby worked plus the hours that Adam worked is equal to what? 48. And so this really becomes almost like a little bit of a system that we talked about in 8th grade math, right? And so this is going to substitute here. And so we get 2a plus 3 plus the a is equal to 48. And so we will add the a's together. So we get 3a plus 3 is equal to 48. And we will subtract the 3. We're just solving this equation at this point. And so our final step here is that we'll divide both sides by the 3. And we get that a is equal to 15. So what does that a equals 15 represent? Is that Adam worked how many hours? And if Adam worked 15 hours, we're going to take this back now and figure out for Bobby. And so 2 times the 15 plus 3 is our Bobby. So B is equal to 30 plus 3. So B is equal to 33. So Bobby worked what? 33 hours. And so this is our answer because it asks what? How many hours did they work, right? It didn't ask us just for Adam. It didn't ask us just for Bobby. It asked us for both of them, right? And if we take the 15 plus the 33, we get a total of what? 48. So that's it for this lesson. Make sure you fill out your Google form for this lesson. Make sure that you have done what you need to do. Make sure you've taken your notes, y'all. and I hope y'all have a great one, and I'll see you next time.